Good day. I'm Joanna Nulhati, and together with my groupmates, Ms. Mahinan, Mr. Bandahala, Mr. Mandap, and Mr. Madula, we will be presenting the maintenance and rehabilitation of prestressed concrete structures. To start off our presentation, I will be calling Mr. Bandahala.
Good day, I'm Aaron B. Bandahala. My report is all about fundamental objective. So, to preserve the structure in such a way that it will function satisfactorily at the various limit stages immediately after construction, and also over the period covering the lifespan of the structures. Good maintenance practice requires periodically surveillance, identification of local damage, deterioration, and loss of durability of the structures due to environmental and other load effects. In prestressed concrete structures, the primary problem encountered is the damage caused to the anchorage and unbonded tendons due to rusting under exposure to humid weather conditions. The maintenance management system must provide guidelines and methodologies to enable engineers to reach rational, cost-effective decisions regarding maintenance and rehabilitation of distressed structures. According to Gokil and Rora, periodical inspections, repair, and rehabilitation constitute the primary aspect of good and effective maintenance. It is more prudent to inspect the prestressed concrete structures at regular intervals for detections of any signs of deterioration and or distress and initiate rehabilitation methods, thus restoring the structure to a state of full serviceability. Maintaining prestressed concrete structures of various types in a fit and serviceable condition is the primary function of a maintenance engineer. It is always advisable to establish a proper preventive maintenance system to detect any signs of distress at the initial stages, through inspection procedures and appropriate repairs. During the last decades, structural engineers and builders of major structures have recognized the importance of proper maintenance as a prerequisite to ensure safety and serviceability of the structures during its lifetime. And then, developments in the field of instrumentation has resulted in various types of instruments which could monitor the strength of in situ concrete, cracking in concrete, and rusting in reinforcement. Methods have to codifies to evaluate the in situ strength of slabs to sustain the design loads by actual loading of the panel and monitoring the deflection developed of the soffit of the slab. Structural concrete panels and beams exhibiting distress can be repaired by external bonding of steel plates to the soffit by using epoxy adhesive. Hollows, honeycombs, and cavities in concrete can be repaired by the process of gunneting and shortening applied pneumatically with impact force. To be continued the next episode, may I call on Ms. Paila.
I'm Sharon May Palilan, I will be discussing the inspection of structures. All types of remedial and preventive maintenance of minor repair work, including replacement of components, should be planned at periodical intervals without inconveniencing the users of the structures. In case of prestressed concrete bridge structures, three categories of bridge inspection are necessary to collect the performance data of bridges according to Leana. Under this category, general inspections are carried out quickly and frequently by highway maintenance engineers having reasonably practical knowledge of highway structures. This type of inspection required to identify fairly obvious deficiencies which could lead to accidents or major future repairs or maintenance problems. Routine inspections should be done at intervals of 1 or 2 months. Detailed inspection. This type of inspection can be further divided as general and major, depending upon the frequency and extent of inspection respectively. General inspection is normally made annually. It should cover all the structural elements and it is mainly a visual inspection supplemented by standard instrumental aids, invariably followed by a written report. Major inspection. It is generally more intensive, involving detailed examination of all even requiring setting up of special access facilities where required. This type of inspection is spaced between 2 and 3 years or maybe at smaller intervals for sensitive structures which are exposed to aggressive environments. Special inspection. Special inspections are resorted to under extraordinary situations such as earthquakes, high intensity or abnormal loadings, floods, etc. These inspections should be exhaustive, including structural testing and computations using structural analysis. Experienced engineers should be involved in the investigation. Continue with the report. May I call on Ms. Joanna Lawalhati.
Good day, I'm Joanna Luwalhati and I'll be talking about the inspection of instrumentation. So, prestressed concrete structure showing visible signs of distress in the form of surface crack. Spanning of concrete should be subjected to special inspection using instruments to assess the extent of damage to structures. Also, modern testing equipment which should be of use to the specialized inspection are shown on this side of the presentation. These are types of inspection instruments that are usually used. The first one is the rebound hammer, and it is for in situ evaluation of compressive strength or grade of concrete. The second one is the ultrasonic pulse velocity apparatus, and it is used for detection of cracks in concrete. The next instrument is the snooper crawler and adjustable loaders. The next one is the magnetic detector, and it is for measuring thickness of concrete cover and for locating reinforcement bars. The next instrument is the electronic strain gauge, and it is for measuring of strains in concrete and steel. The next one is the hydraulic jacks pressure transducers or loading cells, and it is for measurement of forces. Cracks in prestressed concrete members, remedy and repair. So in prestressed concrete members, cracks may develop due to a variety of reasons. Concrete can crack in its plastic phase when it is still not set due to plastic shrinkage and settlement. Concrete during its hardening phase is likely to develop cracks due to constraint to early thermal movement and or drying shrinkage or due to differential statement of supports. To call on the next speaker for this presentation, I'll be calling Mr. Banda.
And to continue the report in cracks in prestressed concrete members, remedy and repair. In its hardened state, concrete can crack due to overload, faulty construction, inadequate detailing, sulfate attack on cement concrete, alkali aggregate reaction, and long-term drying of shrinkage. In the case of prestressed concrete, I-section girders with thin webs, crack may develop due to shrinkage, temperature, and loads in the web of the girders. This can be prevented by suitable detailing of web reinforcement to resist the shear force. Horizontal reinforcement uniformly distributed over the depth of the web prevent the shrinking cracks, while vertical reinforcement and the diagonal tension cracks. When there are instances of multiple dormant random cracking in the soffit of deck slab and the side face of the longitudinal and cross girders, epoxy resin injection or grouting and sealing techniques may be successfully adopted. In epoxy injection method, crack as narrow as 0.005 mm can be sealed. This method has been successfully used in repair of cracks in buildings, bridges, dams, and other structures. In the case of dormant cracks wider than 1 mm, it is more economical to use the grouting and sealing technique. This method involves enlarging of the crack along its exposed face, and then the crack is cleaned and grouted. 3 types of sealants. The first one is mastics. Mastics are asphalt with a low melting point with added fillers or fibers. They are the cheapest of the sealants, but their use should be restricted to vertical situations or those not exposed to traffic. The next one is thermoplastics, comprising of asphalts, pitches, or coal tar, become liquid or semi-viscous when heated. And the last one is elastomers. It includes a wide range of materials such as polysulfides, epoxy polysulfides, polyurethane, silicones, and acrylics. These materials are advantageous since they can be used without heating. They have an excellent adhesion to concrete and are not susceptible to softening within the normal range of ambient temperatures. And to continue with the reporting, may I call on Mr. Matula.
To continue the report, I am Kajer Natulak to report the reverse and rehabilitation of structures. The rehabilitation of a distressed prestressed concrete structure involves strengthening of the damaged portion, and this is influenced by the degree of damage suffered by the structure. Minor damage requires superficial patching by using epoxy grout or uniting using shotcrete. Moderate damage involves extensive spalling and cracking of concrete. It is recommended that welded wire fabrics be attached to drill dowels placed at about 500 mm spacing or to existing reinforcement in the damaged area. Severe damage. Severely damaged prestressed concrete girders requires a detailed structure analysis and a design check based on the condition of the damage and the best engineering assumption and judgment. Repair and rehabilitation of damaged or exposed concrete is done by removing the unsand or loose concrete by providing temporary supports to the girder to relieve dead load stresses. In the case of prestressed concrete, bridge decks, special stress checkup is essential before starting the repair works. Bridge girders located in the zones of very severe exposure conditions are likely to suffer extensive swelling of concrete, exposing the reinforcement. In such cases, the unsunk or loose concrete around the girders is removed and repairing against the loss of concrete section is done by jacketing the girder using a steel form. The gap between the girder and the steel box is filled by epoxy concrete grout. Pre-tension prestressed concrete members may get damaged during transportation or due to collisions. In such cases, damaged portion can be repaired and rehabilitated provided the damage is only local and not extensive so as to rule out the use of structural element. The figure shows the method of preparing the bottom flange of a pre-tension girder partially damaged at the sides so that the high tensile wires or strands are not exposed. The damaged portion is cleaned and dowel bars are introduced into the drill holes to a depth of not less than 75 millimeters, and are covered using mortar or not shrink rod. If the damage extends over a large depth, covering the sloping sides and a steel wire mesh is embedded and repaired by applying mortar or non-shrink rod. In some cases, the damage is severe or deeper so that the high tensile wires and strands are exposed. The damaged portion is repaired by using links and dowels along the wire mesh type to the reinforcement. The entire damaged part is repaired using mortar or non-shrink rod. Restoration strength of prestressed concrete girders. Due to various reasons, such as corrosion and reinforcements, due to extreme exposure conditions, especially when unbounded tendons are used, the high tensile strands may get damaged, resulting in loss of prestress to the girder. The damaged strands can be effectively spliced or strengthened by external forces. The following strengthening methods can be conveniently used to restore the strength of damaged prestressed concrete buildings. Method 1. In the case of damaged prestressed concrete, I-girders post-tensioning rods in conjunction with jacking corbels located outside the damaged areas can be used to restore the strength of prestressed girders. Method 2. In this method, the damaged concrete is first repaired by applying the required preload and the concrete corbels are constrained with the required conventional steel reinforcement. Method 3. In this method, preload is applied prior to the repair of the damaged concrete and removed after the completion of the repairs. In many cases, it becomes necessary to increase the load bearing capacity of an existing reinforced or prestressed concrete girders due to various reasons. According to Reynolds, two fundamental methods of strengthening or repair are possible with epoxy resin adhesive, which are the depth of the structure elements is increased by adding a new layer of concrete on top of an existing cross-section and banding the old and new elements with modern epoxy resin adhesives. The total reinforcements in the cross-section is increased by epoxy banding of thin steel pins on the tension face of the beam to increase the flexural and shear strength.
Thank you for listening to our report about the maintenance and rehabilitation of pre-stressed concrete structures.